All right, so chapter 11, of course, is all about derivatives. And in 11.5, we talked about how to calculate the derivative using the power rule, which was kind of our basic multi purpose, generic rule. We do want to talk more about some other situations that we could be in, namely being products and quotients. And we'll talk more about what those are. But we're going to rewrite products multiplication into polynomials. We will use the quotient rule, and you'll just kind of have to just follow along on that. And then we're going to apply the quotient rule to the marginal average cost, okay, and what that means. And I want to talk about again. I know I've mentioned it already, but again, what a derivative really does. Okay, so a derivative allows us to have this function, right? Of some kind. Okay, and it's a nonlinear function, as you can see, and it will have a tangent line. Okay, the tangent line is the line that touches at a single point, but its slope matches the slope of the function at that point. Okay, so say I go to x is equal to 2 on my function, and then I can't look at that and tell what the slope is or how much it's changing there. But I can calculate a derivative of the function, evaluate it at x is equal to 2, and that will tell me what that slope was there, okay? So that's what a derivative does for us, okay? So it's a very important concept. All right. So first we want to talk about rewriting products into polynomials. And so if we're given a product, the textbook has a product rule that you can use technically, but for the size of functions that we're going to be dealing with, I think this is an easier thing to do. So we're going to rewrite it into a polynomial function, just meaning we're going to have something x squared plus something x plus 4 or something, okay? And then we can find the derivative. All right, so all I'm going to do first is some algebra steps. I'm doing no calculus here. All right, I'm going to take that first one, and I'm going to distribute that 8, or that 8x, okay? So I'm going to distribute the 8x to the 2x squared, right? So I have 8x times 2x squared. And then I'm going to distribute the 8x times 7. Yeah, just applying the distributive property there. All right. So now that I've done that, I'm going to go ahead and multiply and just do my algebra, right? So 8 times 2 is 16. X times x squared, that's an exponent rule. We add the exponents. So that's x cubed plus 7 times 8 is 56x. Okay. Now I'm in a position that I can take the derivative of this function. Okay, so I can just employ the power rule here, and I can take the derivative. All right, the power rule says that I bring my power down, so I'm dealing with the 16x cubed now. I bring the power down, and I multiply it by whatever's out front, so 3 times 16, that's 48. X, and then my new power is the original power minus 1. So 3 minus 1, which is 2. Okay. So that's the first term. The second term, the derivative of x is just 1, but it would end up being 1 times 56. So the derivative of anything that has just a plain x is just that, anything. So for this one, it would be 56. Okay. And so that is the derivative of that product that we originally had. And we did not have to employ any new rules. All we did was some algebra and was able to take the derivative from there of the polynomial. All right. For g of x, I'm going to have to use what we refer to as FOIL. Just do the distributive property twice with the first outer, inner, last. So go ahead and pause the video, and I'm going to erase what I have here, and then try to solve that g of x and see how far you can get. All right, so I'm assuming you paused the video. So again, I'm going to do my algebra first, which is just foiling. 2x times 3x, that gives me 6x squared. My outer is 2x times 5, which is 10x. My inner is 4 times 3x, which is 12x. And then my then my last is 4 times 5, which is 20. Okay. I can combine those middle terms. So 10x plus 12x is 22x plus 20. And now I'm in a position that I can do the power rule. So I have g prime of x, which is just says I'm taking the derivative of it. Power rule says I bring the power down and multiply it by whatever's out front, and then subtract 1 from the power. So 2 times 6 is 12x. 2 minus 1 would be 1, so I just have a 1 or a plain x there because I don't have to write the 1. All right, just like we had with 56 on the last one, it's 56x. This one I have 22x, and so the derivative of 22x would be 22. All right, the derivative of 20 is 0 because it is a constant. So therefore, my derivative for that function is 12x plus 22. All right, and that's all I need to answer. All right, so now the quotient rule. So the quotient rule is something that students normally do like because it's so blatantly obvious when you should use it and when you don't, and quotient being division. Okay. I'm going to give you the formal definition of the quotient rule that the book gives, and then I'm going to give you kind of my personal definition. You're welcome to use whichever one. They're both the same. It just might be a little easier to remember, but this is definitely one that you're going to want to have written down. Okay. The formal definition that the book gives you says f of x, when f of x is equal to some u of x divided by v of x, then, and it uses u of x and v of x just to say it's some kind of polynomial on top and on the denominator. Okay, the derivative of this function would be we copy the denominator, we multiply it by the derivative of the numerator, then we subtract the copy of the numerator, and we multiply it by the derivative of the denominator. Okay? And we divide that whole thing by the denominator squared. Okay. For me, that's a lot of u's and v's, and the order does matter because I have subtraction, so I have to make sure I get those in the right position. All right, but the order does matter. So here is how I remember it for me personally. Okay, let's say that f of x is written and some kind of, and we'll call them high and low. All right. So then the derivative of f of x is equal to low d high, so the derivative of the high, minus high d low, So the numerator times the derivative, d for derivative, of the denominator, divided by low, or low squared. Okay, so it would be low d high minus high d low divided by low. Okay, that is how I remember the quotient rule for me. Okay, you're welcome to use whichever one you want to. Whatever helps you understand it is great with me. Okay, so now let's put this into practice. Okay, so let's answer a few here. So we have this f of x, and I'm going to use the low d high stuff. Okay, and something that you can do, and I actually advise you to, go ahead and label out your what each thing is, the high, the low, the d high, d low. So high for here, for the f of x, would be 2x minus 1. The derivative of the high, d high, would be 2, because the derivative of 2x is 2. Derivative of negative 1 is 0. Low is 4x plus 3. And then that makes d low 4, because derivative of 4x is 4, derivative of 3 is 0. Now I can just fill in my position. So I need low times d high, which is 2, minus high, which is 2x minus 1, d low, which is 4, all divided by low squared, which is 4x plus 3 squared. Okay. And that is the derivative, so I need to make sure I have my little prime, or my apostrophe there. All right. So now your calculus is over. Okay, so calculus is done. So now we just have to do the algebra just to clean it up and simplify it. Okay, so I'm going to go ahead and distribute here in my numerator with the 2 and the 4. So 2 times 4x is 8x. 2 times 3 is 6. All right, I do have the subtraction sign in the middle, so I have to be very careful. So that is negative 2x times 4, which is negative 8x. I have negative times negative 1, which is positive 1 times 4, which is just positive 4. The denominator, I'm just going to leave it in this 4x plus 3 squared. Okay. There's no benefit to expanding it out, so I'm just not going to do it, because it would just be a waste of time. Okay. Now I can combine my like terms. I have 8x minus 8x, that's 0, so that's nothing. I have 6 plus 4, which is 10, divided by my denominator squared. And so that is the derivative for f of x. Okay, so again, I just copied out the low d high stuff, and then I just plugged it into what I needed, and was able to just calculate a derivative for that function. Okay, so as you well know that I like to do, go ahead and pause the video, try h of x, and you're welcome to label the high d high, low d low, and plug in. So go ahead and pause the video and try h of x, and then unpause it when you think you have an answer. All right, so I'm assuming you paused the video, and so let's figure out what our derivative is. It does look a little different because we have an x squared now, as opposed to just a plain x, or some kind of just first power of x. So my high is 7x minus 3. My d high then is 7. because the derivative of 7x is 7. My low is x squared minus 8. So my d low, I'm using the power rule here. I'm going to bring the 2 out front. That becomes 2x. My new power would be 2 minus 1, which is 1. So I'm good there. Negative 8, the derivative of that's 0, so I can just ignore it. Okay. So now I have all the necessary information that I need. So low, x squared minus 8 times d high, which is 7, minus, let's see, I have high, 7x minus 3, d low, which is 2x. Almost ran out of room there. All right. All divided by low. So x squared minus 8 squared. Okay. So now my calculus is done. So I can just take I can just do the algebra. Okay. So I want to distribute the 7. So I have 7x squared minus 56. I got that subtraction in the middle there, so be careful. I have 2x times a negative 7x, which is negative 14x squared. And then I have a negative times a negative 3, which is positive 3 times 2x, which is 6x. Let me erase that and redo that. Doesn't look great. All right. All divided by that denominator. The denominator is just going for a ride, okay? So it's just tagging along. Now I can combine my like terms. So I have some x squareds. So I have 7x squared minus 14x squared, which is negative 7x squared. We do usually like to write these in the order of the degree of x. So I'm gonna swap where 6x and 56 are. So I have positive 6x minus 56, all divided by x squared minus 8 squared. And that is my final answer. So that is my derivative for that given function. All right. So it's a little bit aggravating to do, but I mean, it is just kind of an algorithm or rudimentary that you just kind of do it. Once you get the hang of it and do it a few times, it'll be kind of second nature, okay? All right, so the quotient rule is fun because it does have a purpose, okay? The quotient rule is used when we want to find the marginal average cost, okay? The marginal average cost is the derivative of the average cost, okay? So the marginal average cost, marginal is just slope. It just means the difference in producing one more item. And here we're talking about the effect on the average cost, and which is the derivative of, and that's the derivative of the average cost function, okay? This average cost function is represented by this C bar of x, which is we just take the cost function and divide it by x. Okay, so that's all we're going to do. Then we're going to take the derivative of that, and that's where the quotient rule comes in. Okay, so let's say that we are producing birthday presents, or whatever you want to say there. And the cost function for that is represented by x squared plus 3x plus 18. And x represents 100 presents, 100 presents, okay? So we want to find the average cost function and then evaluate the average cost when x is 2, okay? So x squared plus 3x plus 18 is our cost function. And I am trying to find C bar, okay? C bar, or just is the average cost function. So I'm going to take my cost function of x squared plus 3x plus 18, and I'm going to divide it by 2. No, excuse me, I'm not dividing it by 2. Getting ahead of myself here. I'm going to divide it by x. Okay. That is my average cost function. So what does that allow me to find? Right? Obviously, again, it's not linear, which is okay. Then this allows me to say, all right, well, when I'm producing 200 items, my average cost to produce 200 items is so much per item, right? And that's what we're going to find out. So I want to find when x is 2, so I just plug 2 into this function. So I plug 2 into the function, plug in the calculator, and you're going to get 14. And we're talking about money, so we'll just say it's $14. So this tells me now that it's going to cost me, if I want to produce 200 items, it's going to cost me an average of $14 per item to do that, okay? That may help me with how I want to price my items. It may help me with how I maybe if I need to hire more people, etc. Whatever the costs can have an effect on, okay? So that tells me that at 200 items, it's going to cost me $14 per item on average. All right. Now the marginal average cost function is the derivative of the average cost function, which we figured out to be x squared plus 3x plus 18, all divided by x. So now I want to find the derivative of that function, okay? I'm going to just use that high d low. So high is x squared plus 3x plus 18. So my derivative of the top, or the high, is 2x. All right, just using the power rule, plus 3. Okay. My low is x, so that's not bad at all. My d low is 1, so the derivative of x is 1. And so now I can find the derivative of that function. Okay. So low is x, d high is 2x plus 3, minus high, which is the x squared plus 3x plus 18, times d low. Well, d low is just 1. Okay. All divided by low, or x squared. Okay. Calculus is done. Now I'm just doing algebra. Distribute my x, I get 2x squared plus 3x. Okay. All the stuff in the x squared plus 3x plus 18 is just get multiplied by 1, but there's a negative out front, so the sign just changes. Okay. Now I can combine my like terms. I have an x squared, or 2x squared minus x squared, so that is x squared. I have 3x minus 3x, that's 0, so I'm good there. Minus 18, all over x squared. And so that is my marginal average cost function. Okay, so this will tell me the slope of the average cost at any point that I choose. Okay. So let's evaluate this for 200 and 500. Remember that I said x represents 100 presents. Okay. So I need to find when x is 2 and when x is 5. Okay. So I'm going to evaluate my derivative of c bar, at x is equal to 2. Okay. So I'm going to have 2 squared minus 18 over 2 squared. Okay. And that comes out to being 4 minus 18 divided by 4. Is that right? Yep. So I have 4 minus 18 over 4, which is negative 14 divided by 4, or negative 7 over 2. Okay. So what does that tell me? That tells me that when I found the marginal average cost at 200 items, that it tells me that it was trending down or had a slope of negative 3.5. Okay. I'm going to do the same thing for 5. All right. 5 squared minus 18 over 5 squared comes out to 7 over 25. And so that tells me when I had an average, or when I, at 500 items, my average cost changed from $4.99, changed by 7 over 25. Okay, so the average cost increased. At 200 presents, the average cost decreased. So maybe I could use that to then find something that, is kind of the minimum cost for me, but maybe a maximum profit. Okay, so that is the application for the quotient rule, and that sums up our 11.6. It finishes up chapter 11. If you have any questions, please feel free to email me, and have a great rest of your day.